Figure 13.1, Divide by Zero Exception Handling.java. This is our first introduction to the concept of exception handling in Java. The basic idea is that exception handling enables you to make your programs more robust by adding in code to your programs that can trap problems as they occur and enable you to either keep your program up and running as if those problems had not occurred in the first place, or at least give you an opportunity to terminate a program in a nicer manner than simply having it blow up in front of the user of that application. So in this first example that we're going to be looking at, we're actually going to show you what happens when you don't trap runtime problems as they occur. And then we'll go ahead in the next example and show you how to grab those problems when they happen and hopefully recover from at least some of those problems. So this first example consists of a class that has a static main method, and of course main is always static. And it also has a static quotient method, which is going to receive a numerator and a denominator value, and it's going to simply try to return the numerator divided by the denominator. Now, when you do integer arithmetic, and in particular integer division, you cannot divide by zero. If you do divide by zero, the language itself is going to quote-unquote throw an arithmetic exception. An arithmetic exception is an indication that something went wrong during arithmetic, and in particular, division by zero is one of the things that can cause such an exception to occur. So one possible problem in this example is division by zero. If you're doing division with floating point numbers, Java uses the IEEE 754 standards for floating point numbers, and in IEEE 754 you are in fact allowed to divide by zero, and the result will either be a positive or negative infinity value depending on what the numerator was in the first place. Now, in main of this example, we start out at line 15 by creating a scanner object to read values from the user at the command line, and then we prompt the user to enter an integer for the numerator. We then use the scanner class's nextInt method to obtain that integer and assign it to our variable numerator. We do the same thing for the denominator, first prompting the user to enter the denominator and then reading in with nextInt the next integer and storing it into the integer variable denominator. If these two statements work correctly that do the input, we will then pass those values off to the quotient method, and when I am invoking one static method from another static method of the same class, I can simply use the name of that method. The quotient method will perform the division, and assuming it's not a division by zero, will return to me the appropriate result. That result will be stored into our variable result, and then we will output the numerator, denominator, and result at the end of main. Now, what we want to do is run this program for you 3 times, once to show you a successful execution of the entire program, once to show you what happens when you attempt to divide by zero, and once to show you what happens either on line 18 or line 20 if you type a non-integer value when the scanner object is expecting you to give it an integer value. And part of the discussion in this example is going to be to show you the online documentation set once again, so that we can talk about how you learn whether or not a method of a given class throws exceptions. So let's take a look at a command prompt here, and I'm running this from the command prompt because we use in this example the exception handling capability where it displays what's known as a stack trace when a problem occurs, and also because in NetBeans, when you're doing interactive prompting and reading from the command line, if you don't use system.out.println, then the prompts don't always show up in the correct order within the development environment, which is a bug in how NetBeans renders the results of system.out.print statements. So I'm going to execute this from the command line here by typing Java and the name of the class, which will launch the Java virtual machine and load up this class. And you'll see that it now prompts me to enter the numerator. So let's say I type 100. and then it wants the denominator, and I'll type a valid non-zero value like 7, and it gives me back the valid result. And notice it comes back as a whole number because I'm doing integer arithmetic, and integer arithmetic always yields integer results. Well, now let's take a look at what happens when we do this program again, or run this program again, but we type 0 for the denominator. So again, I'll type 100 for the numerator, 0 for the denominator, and now I get an exception stack trace message showing you that we attempted to divide by 0. You'll notice as part of this message that it says exception in thread main. The main thread of execution is the one in which the main method launches the program. And the type of the problem that occurred in this case is an arithmetic exception. It even tells you the package where you can find the definition of arithmetic exception. And to the right of the type is the error message string, which in this case uses the / to represent division, and then the words by 0. So division by 0 was the problem. Then we have a series of @ lines, in this case 2 @ lines, showing us what the methods were in the method call stack at the time that the problem occurred. So what we can see is that the problem occurred at the DivideByZeroExceptionHandling class's quotient method in the file DivideByZeroExceptionHandling.java at line 10. Well, if we go back to line 10, you can see that's where we were attempting to divide, and in the denominator at that point was 0. Also, it shows us that the exception stack included the main method in that same file at line 22, and if you look at line 22, you'll see that's where we actually called the quotient method. So as this program is executing, when main first gets called, main gets a stack frame on the method call stack, and when main calls at line 22 the quotient method, then we have a stack frame for the quotient method at the top of the stack, and at line 10 inside of that method is when the problem actually occurred in this example. So as you look at any error message like this function call stack trace, you always want to go top to bottom through the lines that start with @, looking for the first line that includes your class name and a method of your class, so that you can figure out what line number caused the problem in your class. Chances are, if you're calling off to one of the classes in the Java APIs and it then throws an exception back at you, that the problem is probably a value that you passed into that method in the first place. Now we're going to run this one more time, and this time we're going to show you what happens if you type a non-integer value for one of the values that are being read in by the program. So let's say I type the word hello here rather than an actual integer value. When I press enter, I get another stack trace showing me what went wrong. And as you look at the @ lines, you'll see that the first 4 of the lines show you java.util.scanner and then methods from the scanner class. And those methods, yes, they did initiate the problem, but the problem was caused by a value that we were passing into the methods of that class. So at the last @ line, we see that it was our class's main method that caused the problem, and it happened at line 18. Well, if we go back over to line 18, that's where we were reading in the first value, and what happened is it read in a value that was not an integer, so it threw what we call an input mismatch exception, indicating that the type that was being input does not match up with the type we were trying to read, and therefore it could not convert the value we typed into a proper numeric value in this case. So there's 3 possible flows of execution through this program: a successful execution, an execution in which we try to divide by 0 and we get an arithmetic exception, and then an exception of type input mismatch exception if we try to read in a non-integer value. In the next program, we're going to show you how to trap the divide by 0 exceptions, or the arithmetic exceptions rather, and the input mismatch exceptions. Now separately, how do I know when those exceptions are possibly going to occur? Well, in the case of the arithmetic exception, this one is really being thrown by the language itself. There are some exceptions that can be thrown by the language, and to learn about those you would actually have to read the Java language specification, which talks about all the details of the language. However, for any classes from the Java APIs, you can look at the online documentation set to see if methods of those classes throw exceptions. So let's take a look at the scanner class in the online documentation set, and I'm going to go to its method listing, and in particular we were using the nextInt method, and you can see that method right here. You'll also notice that right here it's just a very brief introduction to the method. However, when you click the link for the method and go to its detailed description, you'll not only see an overview of what the method does, you'll also see what it returns, and if it throws exceptions, you'll see this section in the description as well. And in this case, you can see that there's actually 3 different types of exceptions that could occur. An input mismatch exception if the next token does not match the integer regular expression or is out of range. Well, what that means is an integer regular expression is going to specify the characters that the user is allowed to type, and that would represent a valid integer. For example, -7 or 132 would be valid integer values. If I typed an integer that's outside the range of the 32-bit integers in Java, that would be another reason that we'd get an input mismatch exception. No such element exception would occur if there is no more input to be read. An illegal state exception would happen if the scanner were closed. That would mean that the actual input stream that the scanner is reading from has been closed. Now, in our program, we focused just on the concept of input mismatch exception, but knowing that all 3 of these are possibilities, we might want to write our programs to deal with those problems. Now, when we show you how to deal with an input mismatch exception, for the moment we're going to ignore these other 2 possibilities. So now, as you're using the classes in the online API, you want to look at this online documentation, and for every single method you choose to use, you want to look and see if that method throws exceptions. And there, as we're going to learn, there's actually 2 different categories of exceptions in Java. There's one category of exceptions where you don't really have to deal with those exceptions in your program, and the program will compile fine. And then there's another category where the compiler actually forces you to deal with those exceptions, and we'll talk about that a little bit more after the next example.
Looking to advance your career by acquiring new skills? Tired of expensive off-site training programs? Wish you could learn from the best instructors in the industry? Look no further than Live Lessons, self-paced personal video instruction by the world's leading technology publishers. Each live lesson comes with a DVD featuring 3 to 4 hours of instructor-led classroom training, sample program code that allows you to work along with your personal instructor, and an example-rich study guide. Live lessons allow you to watch the entire course from start to finish, or navigate directly to any of the individual lessons. You'll literally watch over the shoulder of your instructor as he shows you how to build state-of-the-art applications. Live Lessons, the power of the world's leading technology experts at your fingertips. To learn more, visit mylivelessons.com today.